The diagram shows the graph of the curve y equals log e log of x to the base e in this domain 1:4. Use the trapezoidal rule to find the approximate area of the region enclosed between the curve, the x-axis, and the line y equals to 4. Give your answer in this form. Okay. So I suppose the first thing to understand is if it is log to the base e, another way of saying that is natural log. It's in the domain between 1 and 4. So, even if we just make a little sketch, so that's 1, that's 2, that's 3, and we know this is the line 4. So they would be our x values. Now, the corresponding y values, well, you can try them out. So for example, if y is equal to the natural log of 1, so if you do the natural log of 1 on your calculator, you'll notice it's 0, which makes sense. So when the natural log is 1, the answer is 0. If you try the natural log of 2, now you're not asked to do this, but just to give yourself a sense of what's happening, 0.6931. So would that make sense? I guess so. If we were doing the natural log of 3, we get 1.09, etc. So that would be there essentially. And then if we did the natural log of 4, we get 1.38, etc. So essentially we know that is the natural log of 4. That would be the natural log of 3. Now you could put in the values if you wanted to, but you can even see there that makes sense. Like the first one is lower, the next one, they're all a little bit higher. So it'll just give you a kind of a sense of where this graph has actually come from. Now, anyway, it says use the trapezoidal rule. So use the trapezoidal rule to find the area between the curve and the x-axis and the line x equals to 4. So we're talking about where I have the yellow highlighter. Now, when we're doing the trapezoidal rule, so, and in fairness, most of you were able to find that from your log tables, so that was good. When you go to fill it in, some of you got a little bit mixed up between like what were supposed to be the gaps and what your x values were. So if we, first of all, sorry, I'm just gonna get the formula here. Now, while I write down my formula, I suppose normally we kind of write it as gap over 2, so h over 2. So I'm just copying this down from the log tables, but the way that I actually use it, and the way that we've learned it in class is really, we think of all of this, so it looks quite complicated, but we understand that in fact, it's really just the gap over 2, first plus last plus twice everything else. So if we look at this in that context, the gaps are all just 1 unit. So that's why it's 1 over 2. Our first is 0 because it goes into a point. Our last, so what's our last? Well, if we think about what would constitute our last in this particular case, we can see that it would be the natural log of 4. Now you could put in a value, but what we want to know is the length of this. So the exact value is the natural log of 4, or you could, if you wanted to, you could use what we figured out on the calculator, but you will get a slightly more accurate answer if you just leave it as log of 4 for the moment, plus twice everything else. Now, what is everything else? Well, this measure here, which is the natural log of 2. And the next one is the natural log of 3. Now, again, you can put in the numbers there if you want, but sometimes it's easier to leave that until the end. So you're just using your trapezoidal rule here. So we have a half, and now we have 0 natural log of 4. So that's just the natural log of 4 plus twice. Now, if we have logs that are being added, we can think of them as multiplication. So really, you can think of them like that. What else can we do? Well, we can multiply in the half. So natural log of 4 over 2 plus 2 natural log of 6 over 2. So this becomes another way of saying half natural log of 4. The 2's cancel, that's natural log of 6. So we can take that a little bit further. Then we can do the natural log of 4 to the power of a half, because you're just returning that into its original position. Now, when you think of the power of a half, that's square root. So really that's the natural log of 2. And again, if we have logs that are being added, really that's multiplication in our rule of logs. So it's natural log of 12. Remember, natural log can be written as the log of 12 to the base e. So that's our answer for 10 marks. Now it says find the actual area of the region enclosed and hence find the percentage error in your answer in A, part 1. So the trapezoidal rule is only an estimate, and that's why the symbol is approximately equal to. So how do we find a more accurate version of this? So what we really need to do is we need to integrate to do that. So I'm thinking if we were able to get the area of the full region, so if you're able to get the area of the full pink region there, and then you were to subtract away, and we were to subtract away the blue, that should leave us with the yellow. So what I'm going to do is I'm going to get the area of the pink section, which is a rectangle, and then I'm going to subtract away the blue. And if I do that, that leaves me with just the yellow. So let's have a look for that. So the rectangle itself is going to be length. So the length of our rectangle is obviously 4 units multiplied by the width. Now the highest it goes is the natural log of 4. So the best I can do here is say 4 natural log of 4 for my rectangle. Now, if I want to get the blue part, that is the integration between 0 and the natural log of 4 of an expression dy. Now, the reason it's dy is because if I'm going to do the blue bit against the y-axis, so I'm going to do it against the y-axis, then that needs to be in the form of y. Now, in the question, it says y is equal to the log of x to the base e. Now, why can't I do that? Well, why can't I do that directly and just do the integration of the log of to the base e? But if you look at your table on integration, so this is page 26, you'll notice there is no integration of the natural log. You can integrate 1 over x and make it into the natural log, but there is no starting point for the natural log. So for that reason, I'm not integrating the yellow part. I'm integrating the blue, taking it from the pink to get the yellow. Now, in order to put that in here, I need to have a y in the actual question. So I basically have to rearrange this. So my base is e, so it's going to be my, e is going to act as my base. Y is the power, and that should be equal to the answer, which is x. So e to the y is going to go in there. Now, when I integrate e to the y, so if you check your integration, this is literally, it stays as e to the y, to the power of y. And now I just need to input my upper and lower limits. So I have e to the power of natural log of 4 minus e to the power of 0. So e to the power of the natural log of 4 is 4. And e to the power of 0 is 1. So I end up getting 3. So what I need to do is I need to do 4 natural log of 4 minus 3. Now, when I put that into my calculator, I'm getting 2.54517, etc. The estimated answer was log of 12 to the base e. So I better figure out what is log of 12 to the base e. Now, that is me finding the natural log of 12. So I'm going to pop that into my calculator. that comes out to be 2.4849. So they are quite close, but we're looking for the percentage error. So I'm going to take one from the other. So I'm going to have my 2.5451, etc., minus 2.4849. So that gives me an answer of 0.06027. Now I put that over the over my actual, so 2.54517, and then I multiply by 100 to change it to a percentage. So 2.368 to 2 decimal places is 2.37%. So in other words, my trapezoidal rule is out about 2.3% on what it actually is. So my actual is this part here, which is what was the rectangle minus away the integral against the y-axis.